Welcome. This video is going to talk about the development of the periodic table and just some of the big patterns and terms you should be familiar with. So, looking at some of the early developments, in the late 1700s, scientists started looking at how many elements do we already know about and how can we organize them, or is there any organization? So, in the late 1700s, there were 33 known elements. That list has now gone up to 92 total for natural elements. So Newlands organized them in groups of 7, which worked for the first 7, but then there were some problems with it, so it didn't work for all the known elements. So 7 wasn't quite the number we were looking at. And then two fellows, Meyer and Mendeleev, each came up with a very similar idea at the same time, even though Meyer was working in Germany and Mendeleev was working in Russia. They both based their tables on increasing atomic mass as you go left to right, and then similar chemical properties as you come down the columns. And Mendeleev is generally given credit for this table because he happened to publish his idea before Meyer did. Then there were a couple wrinkles, a couple elements that didn't seem to fit where they belonged, and Mosley was the guy who found the problem and solved it. He realized that the table should actually be arranged by atomic number, or the number of protons, not the atomic mass, because there's a couple instances where the atomic mass actually flip-flops elements by their atomic number. So the modern table is arranged to what we call periodic law, which is increasing atomic number with repeating patterns of physical and chemical properties. And what we're really going to look at this year is those repeating patterns hidden in the table. Some common names you should know: representative elements versus transition elements versus intertransition elements, and that's all color-coded here. And then there's 4 main families you should be aware of: the alkali metals, the alkaline earth metals, the halogens, and the noble gases. Other terms you should be aware of is that groups or families are the vertical columns, and there's 18 columns, and you can number them simply 1 through 18, or American tables often label them 1A to 8A and 1B to 10B. Periods then are the 7 rows, the horizontal rows on the periodic table, and there appears to be 2 extra rows at the very bottom, but they actually come up and slide into periods 6 and 7, like opening up your dining room table and putting the extra leaves in for company. So representative elements versus transition elements. Groups 1 to 13 to 18, so the 2 families on the far left and then the 6 families on the far right, those are the representative elements. They also are the A group families, if you number them that way. And they're considered representative elements because they are filling up electrons. Their last electron is going either into an outer s or an outer p orbital. Transition elements are the B families, or that middle section of the table, that lower spot on the table, groups 3 through 12, and their outer electrons are going into a D or F orbital, which is always going to be a floor or 2 behind. Another pattern you should be aware of is that there's a zigzag line that some periodic tables show, and it's way over to the right side, so most of the elements lie to the left of that line. A few of them lie to the right. And the ones lying to the left of the zigzag line are considered to be metals, except for hydrogen, which also ends up on the left side in family 1A. Characteristics of metals are that they're usually shiny when clean, they're solids at room temperature, except for mercury, they're good conductors of heat and electricity, they can easily be flattened into sheets or drawn out into wires, which we call malleable and ductile. And 2 special groups of metals that we tend to look at is family 1 or 1A, the alkali metals, except for hydrogen, of course, isn't a metal. But they have this name because they're very reactive, so they're often found as compounds. And when they're found as compounds, especially if they're dissolved in water, they become alkali or basic. You rarely find them in pure form because of their high reactivity. Family 2 or 2A is called the alkaline earth metals, and they're almost as reactive as group 1A. They're commonly found in Earth's crust, so these are ones that we mine, and they too tend to form basic or alkaline compounds or solutions. Okay, so the transition metals, I said, are group B. Groups 3 through 12 are the B groups, and they're actually divided into what we call the transition metals and the inner transition metals. So the transition elements is that whole group, but the ones that are on the table versus the two extra rows at the bottom make up the transition metals and the inner transition metals. And the difference is that the transition metals are filling up a d orbital, one floor behind or one energy level behind, but the inner transition metals are where we're filling up the f orbitals. And these are really rare, so we aren't going to use these much, which is kind of why they're at the bottom of the table, where it's there if you need them, but most people don't use them. Metalloids, and metalloids are the elements bordering or touching the zigzag line. And every element that has one side of its square from the periodic table in common with that zigzag line is considered a metalloid, except for aluminum. Aluminum actually behaves like a metal. And what makes them metalloids is that they have properties of both metals and nonmetals. For example, silicon is on the nonmetal side of the line, but it also can be a good conductor, at least a semiconductor. And as I mentioned, aluminum actually behaves like the other metals, so that's the only one on the zigzag line not considered to be a metalloid. And then to wrap up, nonmetals, they're to the right of the zigzag line. Not a lot of nonmetals over there. And the characteristics are they're usually dull, they're not shiny. Metals tend to be gray or silver. These are all colors. Sulfur is yellow, phosphorus can be several colors. Many are gases at room temperature. Not all, but many are. They're poor conductors of heat and electricity. And these are not easy to shape into other things. If you put any force on them, they tend to be brittle or to shatter easily. And that's a quick intro to your periodic table.